We can also flag mailing APIs, for instance. We flag functions that change the read-only flag. So, for instance, the set accessible on a field class, we're going to flag that because that you shouldn't use that in your application. We have similar rules for all the categories that are described in Jeff Williams' paper, but we broadened our view and we thought about more examples and how people do stuff. So we have rules for all these things. Obfuscation and camouflage, we flag the usage of a single equals inside an if statement. You should not use a single equals in an if statement, so we flag that in the obfuscation and camouflage. We also flag when you're having the same name for a variable as a common function. If you're doing that, we will flag that in the obfuscation and camouflage. And then the really useful one is if you're trying to decode hard-coded strings, we're going to flag that as an obfuscation and camouflage. That turned out to be a really useful one. We found a lot of issues with this kind of rule. If you decode a hard-coded string, it's very suspicious. It's implicitly saying like, hey, I'm hiding something. So you do not want to have that in your code. So I hope that makes sense. And for the conclusion, I want to hand off to Jacob again.
Thanks again, Matias. All right, we're almost done, guys. First, and particularly for the DEFCON crowd, how do you avoid getting caught? So companies are going to start using technology like this to find insider threats. How do you avoid detection? What's the technique for not getting caught? First off, and one that we've seen used again and again, is make the code look as legitimate as possible. Make it look like real code and make it look like code that fits with its surroundings. If you have a 5-line encrypted string hard-coded at the top of your class definition, it's going to stand out no matter who's looking at it, even if it's just a cursory review to make some other edit. So make it look real. Also, if you can make it benign, meaning it doesn't show up as a pure vulnerability, like that command injection that I talked about in WordPress. That's better, right? The more it looks like application logic as opposed to a vulnerability, the less likely it is to turn up for people who aren't really looking for insider threats. It's good to understand who you're up against. So understand what organizations and security teams are looking for and understand what tools they're using to look for those problems. If you can get access to one of those tools, if you can run, for example, the static analysis tool against your code again and again, you can tweak little attributes of it until it doesn't show up. And this is, of course, a real concern for the defenders. But finally, there's a lot more attention on this problem today. So one way not to get caught would be to just not do it in the first place. I think getting a job on the support team and avoiding the source code altogether would probably be an easier route to wreak some insider damage. So for the good guys, what does this all boil down to? It's really like looking for a needle in a haystack. So you're looking for a huge variety of different tools and attacks that people might use. It's hard to think with this big number 3 in front of my eyes. Sorry. The attackers have a big arsenal of tools at their disposal because they've got the entire programming language or multiple programming languages. If you think of a multi-tier application, they might do some damage in JSP or Java or PL SQL or a native C procedure that no one's ever going to look at. So they have a lot of tools at their disposal. What we've seen for the most part has been they put a lot of planning into this. They think about the code for a long time. They've got it in place a year before they get laid off. It's not a spur of the moment, oh man, I hate my pointy-headed boss, I'm going to go code up something really nasty. Put a lot of effort into these. So they've got a lot of variety available to them, and they have a really large window of attack, much bigger than the period between when the board decides to lay people off and they actually do. Technology can help a lot here. I hope with some of the examples that we showed today, you guys see that static analysis, although is never going to point out smoking guns, is a big help over manual review and can really reduce a multi-million line application into a heat map of areas that a code review can do more value in by focusing on those hotspots. And it's really key that going into it, you don't just rely on technology, but that you have your auditors and the people looking for problems apply the right mindset, right? The things coming out of the static or runtime analysis aren't smoking guns, they aren't vulnerabilities, they're breadcrumbs, they're indicators of a potential problem. And until you get a thick enough pile of breadcrumbs, you're not guaranteed of finding a problem. Thanks very much. I know software is not the usual DEFCON topic, but I appreciate you humoring us, and thanks a lot for coming out today. We'll be happy to take any questions after the fact.